Hi everyone, this is lesson 3.4.3, and in this lesson we're going to look at solving logarithmic equations. Example 1a.
Okay, this question asks us to solve for x, and it's a logarithmic equation here. Now, I'll tell you a story. When I was teaching a long time ago, there was a colleague of mine who was waiting outside my door to ask me a question, and he noticed me teaching this, and then when I went out to him, he corrected me. He showed me rightly that really what I need to be doing here is giving an approach that works for all logarithmic equations. What I was doing was I was showing people how to approach these things differently if the logarithmic equation was set up so that it looked a little differently. And this is what he suggested. And after thinking about it, he's actually absolutely right here. Your first step when you're solving these things should be to bring the logs to one side, okay, constants to the other. Okay, anything with a log in it should be one side, constants to the other, to basically simplify to one logarithm, and that should only take you 2 steps, at most 2 steps, okay? 3, convert to exponential form and solve. Okay, now that's running off the screen, I'm sure. Yeah. So convert to exponential form and solve. Now, I'm going to model that with all of these problems here. So the first thing that I want to do here is bring all the logarithms to one side. Okay, boom, that's done. Now, what I'm going to do is simplify this to one logarithm. Now, I really have to emphasize that as a rule. When you are solving logarithmic equations, the number of logarithms should decrease, not increase. So if you make that mistake of going, well, this is going to be log base 2 of x plus log base 2 of 2 plus log base 2 of x minus log base 2 of 4, if you're distributing the log, that is incorrect. That is not a rule. You can't do that. But addition, okay, becomes multiplication between the arguments. Okay? So I can do that. So I've now combined it into one logarithm. Now I'm going to convert the logarithm to the exponential form, essentially to get rid of the log part of this problem. So this becomes 2 to the 4, okay, base to the exponent, and this will equal x plus 2, x minus 4. Okay, now this is something that I should be quite comfortable solving. Okay, I've done this a lot of times before. This is going to be 16. When I expand this out, this will be x squared minus 2x minus 8. Okay, it's a quadratic. I'm going to want to set that equal to 0. And so I'll take negative 8 and I'll subtract the 16 to get negative 24. And now when I factor that, I will get x minus 6, x plus 4. So x is either equal to 6 or negative 4. Okay, great. Now, I got to check my answers though. Okay, because it is not always the case that all of these solutions work. But the check is actually pretty simple. Let's just take a look at 6. Let's take 6 back up into the original expression here. 6 plus 2 is 8, if I plug it into this argument. 6 minus 4 is 2. Both of those end up with positive arguments. That's okay. That's acceptable. Negative 4. Let's take a look at negative 4. Negative 4 plus 2 is negative 2. Okay, that ends up forcing me to take the log of a negative number. Can't do that. So the answer therefore is x is equal to 6. Now, you're going to see in a little while here that you cannot just ignore a root just because it's negative. But in this case here, that negative forces us to take the log of a negative, and we can't do that.
Example 1b.
Okay, here's another question where we're being asked to solve for x, and it's a logarithmic equation. So, following my friend's rule that he gave us, what I'm going to do is bring all the logs to one side. So this is going to become the log base 3 of 5x plus 2 minus the log base 3 of x minus the log base 3 of 8. And because I've brought everything over, there's nothing left over on the right-hand side. Now, that is actually kind of nice. That simplifies things a little bit. if you remember how to deal with that at the end, okay, we got to watch that 0. Now, I'm going to combine all of these into one logarithm. Remember, don't distribute the logarithm here. That's not a rule. Logs don't behave like that. But I can combine them all by doing this. I'm going to make this the log base 3 of, and remember, I got to work this left to right. Okay, people make a huge mistake when they start doing this division, but they start doing it this way, dividing these two, then dividing these two. Order of operations doesn't work like that. So subtraction becomes division. So that's going to be 5x plus 2 divided by x. And then this expression, all of this here, is now being divided by the 8 there, right? So I'm basically putting an 8 in the denominator here. Essentially, if there's a negative sign in the front, when I combine them, okay, it's going to be, that argument is going to be in the denominator. And this is equal to 0. So now, once I've got it as a single logarithm, one argument, I'm now going to convert forms. Okay, so this will become 3 to the 0 is equal to this combined argument, 5x plus 2 over 8x. Okay, now, here's such a common mistake, but it's such a simple thing. We all know it. 3 to the 0 is what? 3 to the 0 is 1. It's not 0, it's 1. But if you're not thinking about this, or if you're focused on another part of this problem at this moment in time, it's very easy to write the wrong thing down here. So this is 1 is equal to 5x plus 2 over 8x, which means when we multiply that up here, we're going to get 8x has to equal 5x plus 2. Okay, well, let's subtract 5x from both sides, and we'll get 3x is equal to 2. So x is equal to 2/3. Okay, good. That's a nice answer. Now, but let's check and see does it work? So let's take that 2/3 and go up to the original expression here, the original equation. 5 times 2/3 is going to be 10/3 plus 2. Well, positive plus a positive will be positive. Okay, that's okay. That's going to work. 2/3 is positive, so I can take the log of 2/3. That's not a problem. So yeah, that's not leading me to take the log of a negative. That's an acceptable answer.
Example 1C.
Okay, this question, similar to the ones before it, is asking us to solve for x. That's a logarithmic equation. So again, following my friend's rule here, what I'm going to do is I'm going to bring all the logs to one side of the equation. So I'm going to bring that log of 2x minus 1 over. So this becomes the log of 5x minus the log of 2x minus 1 is going to equal 1. Okay, good. Now I left that 1 over there because I want to leave the constants on the other side of the equation. Once they're all over here, I'm going to combine them into one logarithm. Remember, I keep saying it here, do not distribute the logarithm. There's no rule to support that. But subtraction becomes division, so this is going to become the log of 5x over 2x minus 1. Okay, now there's really nothing particularly special about this problem except for this little step right here. When I convert this to the exponential form, if the base isn't written, what's the base? Well, it's 10. So this is going to become 10 to the 1 is equal to 5x over 2x minus 1. Now, it's not uncommon for people to get kind of stumped there and all of a sudden think, oh my gosh, what do I do? Okay, but if the base isn't written, it's 10. 10 to the 1 is just 10. So this will be 10 is equal to 5x over 2x minus 1. Okay, I will multiply both sides by that 2x minus 1. So that's going to give me 20x minus 10 is equal to 5x. Now, I know this is going to bother some of you, but that's okay. I'm going to do it anyway. I'm going to subtract the 20x from both sides. And that's going to get me negative 15x over there. Okay, so subtracted 20. And then I'm going to divide by the negative 15. Negative 10 by negative 15. And again, notice the negatives will cancel. Multiple of 5 will cancel. So we got 2/3 is equal to x. There's nothing wrong. I know some of you don't like it, but there's nothing wrong with 2/3 equals x. Okay? However, just because it'll make some of you feel better, x equals 2/3. So now go back up to the original expression here. Does 2/3 work? Okay, 5 times 2/3 is going to be 10/3. That is okay. That's a positive number. I can take the log of a positive. 2 times 2/3 is going to be 4/3. 4/3 minus 1. Okay, that is still positive. It's pretty close. It's only going to be 1/3 in there, but it's still a positive, so that still works. Okay, so that is an acceptable answer.
Example 1D.
Okay, in this problem, similar to the ones before it, we're being asked to solve a logarithmic equation. Okay, so what I'm going to do here is, again, follow what my friend said. I'm going to bring all the logs over to one side. So this will be the log base 2 of x plus 8 plus the log base 2 of x plus 12, and we'll leave the constant on the other side, so that's going to equal 5. Again, my next rule here is to combine the logarithms into a single logarithm. Okay, do not distribute the logs. Combine them into one log. We want the number of logarithms to get smaller here. Addition becomes multiplication, so this will be x plus 8 times x plus 12 when I put that all together. Okay, and now that I've got it as one logarithm there, now granted the argument of the log is kind of ugly, but that's okay. It's still just one log. I will convert to the exponential form to get rid of it. So this will become 2 to the 5th will equal x plus 8 times x plus 12. Okay? And now I just got to evaluate. Now 2 to the 5, that is going to be 32. And this is going to end up being x squared. What is that going to be? Plus 20x plus 96. Okay? And so now, and I recognize this as a quadratic, obviously, so I know that what I got to do is set that equal to 0. So I got to bring the 32 over. So x squared plus 20x, 96 minus 32 is going to be plus 64. Okay, now I'm looking for factors of 64 whose sum is 20. And I hum and I haw about that, and then I realize that's got to be 16 and 4. So my two values here are going to be negative 16 and negative 4. Okay, now that's interesting, because both of these solutions here, both of these possible solutions ended up being negative. So let's go check at the up at the top here. Let's take the negative 16 to start off with. Negative 16 plus 8. Well, that's going to be negative 8. Okay, well, I can't take the log of a negative, so right there, the negative 16 goes away. Negative 4 plus 8 is positive 4. Negative 4 plus 12 is positive 8. I can take the log of both of those. So it turns out negative 4 is an acceptable solution. Now, I like this question, okay, because most of the time when we're working through these problems, we get used to this thought that if it's negative, we chuck it out in this chapter, but that's not true. In this particular case here, the negative root is okay. Okay, so I like a question that shows us something that's a little bit different. Most of the time that we do this question, yes, the negative we chuck out here. But you got to remember why we're chucking it out. If it forces us to take the log of a negative, that's no good. But if the negative isn't causing us to take the log of a negative, then that's a perfectly acceptable answer.
Example 1E.
So this question here, another logarithmic equation. Notice that this time the base is base b. Okay? Now, doing what my friend said, we're going to bring over all of the logarithms over to one side. Now, it turns out that is everything. Log base b of x minus the log base b of 8. And we brought everything over, so it's now going to be equal to 0. I'm going to combine these logarithms into one logarithm, and remember how that works. Think of it as going from left to right. So this is going to be the log base b of, now, first term was positive, so this is going to be up in the numerator, 3x minus 1. This is going to be divided by x, divided by 8. Okay, so divided by x, divided by 8, those are going to go into the denominator. Now, if you need to do that in more steps than just that, feel free to, but this is where you're going to end up, okay? This repeated subtraction is going to put both of those arguments in the denominator. Don't do it right to left. Do it left to right, okay? And then there won't be any kind of confusion here. Once it's at this point right here, We're going to convert to the exponential form, so this will be b to the 0 is equal to 3x minus 1 over 8x. Okay, and then don't go all weird on me here. B to the 0 is just 1. Okay, don't overthink that. Do something strange with that. B to the 0, so it doesn't matter what the base is, as long as the base isn't 0, but that would have been unacceptable right from the beginning. And now make this 8x is equal to 3x minus 1. Bring the 3x over, so 5x is equal to negative 1. X is equal to negative 1/5. Oops, sorry, can't see that. Now, in the previous question we noticed that there's nothing wrong with a negative solution. Okay, so all we got to do is check and make sure that it doesn't force us to take the log of a negative. Now, as soon as I go up to the question, though, immediately I see this log. And that log, this is just the log base b of that root that we just found. Well, I can't take the log of a negative. Or at least I can't and expect to get a real number as a result. There are no real results to that. So basically, we get no real solution here. Okay, the negative 1/5 just doesn't work.
Example 1F.
Okay, we're going to solve this equation now as well, and this is a little bit different only because of the 2 out front. Okay, so my friend's rule tells me to bring all the logs to one side here, and they are. We start this question with all the logs on one side. But this time here, to get these things together is actually going to require the 2 steps that I had mentioned in previous lessons here. The first thing I need to do is remove the coefficient. So this has got to become the log base 4 of x squared minus the log base 4 of x plus 8 equals 1. Now I can apply the rule for the subtraction here. So because I'm subtracting the 2, there's going to be division. So this will be the log base 4 of x squared divided by x plus 8 equals 1. Okay, so it took me 2 steps to combine it into one logarithm, but this is what makes this question a little bit different than the previous ones. Okay, that's what makes this one a little bit unique. I've got it as a single logarithm equal to 1, so I'm going to convert to the exponential form. 4 to the 1 is equal to x squared over x plus 8. Okay, well, 4 to the 1 is just 4, so no big deal. I will multiply across by the x plus 8, and this will become 4x plus 32 is equal to x squared. It's a quadratic, so I'm going to bring every term over, set it equal to 0. So 0 is equal to x squared minus 4x plus 32. I will factor that. So that'll become x minus 8x. Oh, no, that doesn't work. Isn't that interesting? Oh, yes. No, that doesn't work there. So what am I going to do here? Okay, because I was going to say 8 and 32. Oh, that's because I screwed that up. That should have been negative. Okay, so it's such an easy thing to do here. In fact, I have been talking with a lot of my students about this. When you've got that plus 32 here, remember that you have to subtract it from both sides. Okay, it's very easy for people to see this and think, oh, to make this balance, I got to add it over there. In any case, whatever. No, I don't think anybody was too fooled by that, but it has been an issue of late. So this would be negative 8 plus 4. So x is going to equal 8 and negative 4. Okay, those are my 2 possible solutions. I go back up to the top here. I see right here right away I can't put a negative in there because then I'd be taking the log of a negative, so I can't use negative 4 as one of my roots. But the 8 was okay. Now this is going to cause a little bit of argument here and debate, because the negative 4 does work if you plug it into this equation right here, because negative 4 squared is positive 16. Yes, you can take the log of that, but it doesn't work here in the original statement of the problem, and that is the issue. Okay, if this had been the equation, negative 4 would have been just fine, but it wasn't. It was this one, and I'm not allowed to take the log of that negative, not at this level here. So at this case right here, I would have to kick out that negative 4 root, and so my only answer here would be 8.